Beneath these restless waves lies a forgotten world, a vast, lost country mapped by modern science. This was Doggerland, the true heart of prehistoric Europe.
Somewhere beneath the waves of the North Sea, right now there is a country. Roads it never had. Forests it definitely had. Hunting grounds, rivers, an entire world. For over a century, fishermen working these waters kept dragging up things that didn't belong there. Mammoth bones, antlers, a barbed harpoon carved by human hands. None of it should have been there, unless thousands of years ago, this stretch of ocean floor wasn't ocean floor at all. For generations, fishermen just shrugged it off. Strange stuff in the nets. Nobody thought much of it. But scientists eventually started asking the obvious question. What if this wasn't random debris? What if it meant something? If Britain used to be physically connected to mainland Europe by solid ground, why does almost nobody know this? Keep that question in mind. We're coming back to it around the 7-minute mark. Let's go back, way back. Around 20,000 years ago, the planet was deep in the last ice age. Sea levels were dramatically lower because so much water was locked up in glaciers. And that meant something simple, but extraordinary. The land where the North Sea now sits wasn't underwater. It was just land, connecting Britain to mainland Europe directly. No boat required. For decades, the assumption was that it was a cold, miserable strip of tundra, a bridge people crossed quickly to get somewhere better. Nobody imagined anyone actually wanted to live there, just a place to cross, not a place to call home. In 2026, a team from the University of Warwick set out to actually test that assumption. Properly, scientifically, they drilled into the seafloor, 252 sediment samples, pulled from 41 core sites along what used to be a river system, now sitting under the waves. Months of work, careful drilling, painstaking lab analysis. The kind of science that doesn't make headlines until it suddenly does. And inside that mud, they extracted something remarkable, ancient DNA, genetic fragments preserved in sediment for over 16,000 years. The results stunned them. Oak, elm, hazel, full temperate forest species growing in Doggerland over 16,000 years ago, while Britain just next door was still locked in frozen tundra. No trees, no forests, nothing like what was growing on Doggerland at the exact same time. So how does a forest grow during an ice age while the country right next to it stays frozen solid? The answer is genuinely clever. Sheltered, south-facing valleys trapped warmth. Pockets of temperate climate survived inside an otherwise brutal ice age landscape. And then came the detail that really got researchers talking: lime trees. A species so rare in Ice Age contexts that finding them at all was a shock. They also found DNA from a tree genus believed to have vanished from the entire region 400,000 years ago. Not extinct, after all, just hiding. In Doggerland. Where there are forests, there is food, and where there is food, there are animals. The DNA confirmed wild boar, deer, beavers, even bears, roaming this lost landscape. A full, living ecosystem, not a frozen wasteland at all. And where there's food and shelter, there are people. Researchers now believe Doggerland's forests were rich enough to support real Mesolithic communities, not just travelers passing through, residents. This might also explain a strange gap. Why so little early Mesolithic evidence has ever been found along Britain's coastline? maybe the missing communities weren't missing at all. Here's the scale of what we're talking about. At its largest, Doggerland wasn't some narrow strip of land. It was enormous, comparable in size to many modern European countries. The researchers focused on what they call the Southern River, a major waterway roughly 20 miles long, running through what is now empty seabed. So what happened to it? The Ice Age ended. The glaciers that had locked up all that water started melting, and the sea began creeping back in, slowly, at first. Then, around 8,150 years ago, something catastrophic happened off the coast of Norway. An underwater landslide called the Storegga slide, one of the largest submarine landslides ever recorded. It triggered a massive tsunami. That wave would have torn across Doggerland's coastlines with terrifying force. Entire communities, if they were there, would have had almost no warning. Whoever survived would have watched their world change overnight, familiar coastlines gone, familiar hunting grounds drowned. But here's what's strange. Doggerland didn't disappear in one single catastrophic moment. Some areas of it actually survived the tsunami and stayed above water for another 1,000 years. The real ending was slower and quieter. Rising seas, inch by inch, year after year, swallowing the land for good. By around 7,000 years ago, Doggerland was gone, buried under silt at the bottom of the North Sea. This wasn't an overnight apocalypse. It was generations of people watching the coastline creep closer, watching the rivers change, watching the forests they knew slowly drown. Grandparents would have told their grandchildren about a forest that used to stand somewhere out past the new shoreline, a place that no longer existed. Remember the question from the beginning? Why does almost nobody know Britain used to be physically connected to Europe? Here's the answer. Because the evidence is 16,000 years old, buried under freezing water, and only readable through ancient DNA pulled from mud. We've only had the tools to read this story for a few years. Doggerland was always there, we just couldn't hear it speak, until now. And there's a genuinely unsettling thought hiding in all of this. Doggerland explains gaps in the archaeological record. Communities we assumed simply didn't exist on Britain's early coastline. Maybe they did exist, just somewhere we couldn't look, underwater, forgotten, waiting for the right kind of science to come along. Teams are still out there right now, drilling, sampling, mapping. Doggerland is far from fully explored. Most of it has never been sampled at all. Every new core sample could rewrite the timeline again, push the dates back further, reveal communities nobody has imagined yet. So next time you look out at the North Sea, picture it differently. Not as empty water, as a buried country, with forests, with rivers, with people who watched it slowly disappear beneath their feet. A whole world, 16,000 years deep, still down there, still being read, one sediment sample at a time.